Okay, we are going to pick up where we left off last time, which was Unit 7, Lesson 3. And we had just finished the, what's it called? The first practice, the first 4 practice things. So go there. Don't want that. If you'd like to join the meeting, feel free. Okay, so we left off after the console.log practices, I believe. And let me start a timer. Okay, and so these are medium practices, but medium complexity as we build up through the unit. And the point of these is to see how you actually use return functions, in the wild. And oh, that's the wrong key for that. Let's go like this. There we go. Okay, so we are in bubble 5A. Bubble 5, of course, is one of the ones, put it all together situation. And I don't know if we need all that sound. The point is about making return functions are about like making tool to make things easier. I guess I can turn that off. I don't need everybody's doorbell. I wonder if that shows up on the replay. Okay, so it's about creating sort of side tools that are generic, so that or generalized, so that you can use those anywhere throughout, which is kind of the point of a function. But the more customizable they are, meaning receives parameters, the more things it can do and the more useful it is, of course. Okay, so here on bubble 5A, we have a situation. We're bringing in the various lists, okay, from the data table that are already imported for you. And we have 2 function calls, one to longest shortest, sending a string and a list, okay, and longest shortest with this, the same function call, or the same function sending dogs and dog names. Okay, the longest shortest function is receiving those, and the first one it's receiving is type of list. No, wait, longest shortest sends states. Where is this? Oh, that's right. Okay. Why is type of list isn't used anywhere? Short. Oh yeah, sure. Type of list is just for the output. It's not passed through, which I can't remember if I made a big enough point about this last time. So this function called longest shortest is calling other functions. Okay, the definition, which is the definition for longest shortest receives 2 parameters. One, type of list, which is just for concatenating an output. It's going to be like, so the sentence says, dogs in it or states in it. But there's a function call inside of this definition. This is that abstraction, the higher level function calling the lower level function. But what's interesting here is when this function calls the lower level function, it's passing a parameter to it. And that parameter came from the original call. When a parameter sent, the definition can use the parameter however it wants for the duration of the function. Okay, this one is just the part of the text output in that message. And this one, which, we frequently use in the definition, we are using it, or it's using it as a parameter for the lower level function. And then when that gets sent to the lower level function, it gets received as its parameter. This name and this name don't have to be the same. Okay, this name and this name do have to be the same because this is that definition. This is holding whatever we want to use for it, or it's being received there, and we're shipping it out there. We normally, or we so far have just put actual values in the parameters when we send them, but here we're putting a parameter. We're sending this parameter as the parameter for this one, and when it gets received, this name is only relevant inside of its function. The fact that they're using the same name or the same word for it is fine, but it doesn't really make a difference. This function, longest word or shortest word, knows whatever is in the parentheses when it gets received gets assigned to that word. What it was called here is not relevant. The function that we have that works, okay, the comments, again, super critical for return functions. What does it do? Finds the shortest word in a list. Okay, it's expecting one parameter named list, and its data format or data type is a list. It's for the duration of the function, it is called list. And what's going to be returned is a string, and the string in list with the fewest characters. Okay, so it receives a list, and it's doing that, reducing that, getting a list of numbers and returning the smallest, or in the next case, in our case, the longest, where it's doing that trick where it's going to each one and keeping the lowest one or the highest one. Okay, we have a starting variable that we just give the first element in the list because that way it's at least possibly the, in the case, shortest. And we go to each one and check the length of each one. And if we find a shorter one, that's our running champ. And we keep that and compare that against the rest and keep going. We've done this before with lists, but here we're doing it, incorporating it into a return function so that it can be used all the time just by calling the function and sending it a parameter. Okay, and let's see here. We are looking for, is it returning the string? Yeah, so it's going to be the shortest. We're not returning, that's another thing. We're not returning the length of the shortest one. We're returning the shortest one. And that's important because you need to know how to use the return function. Are you expecting this to be a number? Okay, does that return function call equate or end result as the value of a number or as a string, or like the return data type is as critical as anything. Okay, and the state shortest works and the dog shortest works. We need to program for longest word. I'll give you a couple minutes. You can use the shortest word as your example. Okay, and go. Give it a shot. Give it your best guess. All right, so any sort of these reducing functions, or really this is a basic return function, we need our local variable to sort of gather everything up. And just for keeping straight with the previous one, just call this longest. And any sort of these reducing things, we need the we're going to give it the first element as our starting value, and the name of the list inside of this function is called list, because we're just setting this up for any list to be sent to us. So we just give it index 0 as its starting value. We can't do that thing where We know that it's a list of all positive numbers, so we can start our running champion variable at 0 because we know it'll get replaced. This is being set up for any list where, like, maybe it's looking for the smallest number, like we gave before, where if we give that first running champion variable 0, it could win even though it's not on the list. So we have to do that thing where we give it at least possibly the correct one. And we are, yeah, so we're checking for the actual word. So we're going to end up returning longest. Now, how do we sort through a list? Okay, we're going to loop through list.length. Okay, it's literally list.length this time, although even though up till now it's been saying list.length, it just means the name of the list. But we're doing list.length loops, and we're going to go to each one. And if the one we're checking, which is list index I, if its .length property is greater than our running champion, then we replace it. Okay. If the one we're checking is bigger than our biggest, that is the one we're keeping. Longest gets, yeah, we're only keeping track of, longest, it would be longest.length, excuse me. If the one we're checking the longest variable is holding the name of the state, not its length. So if we're comparing the length of the word we're checking through all of them, we need to compare it against the longest length, or the length of the longest one. And if the one we're checking is longer than the longest gets assigned that new longer one, which is list index I. And when we get through the entire list of lists, longest will be holding the longest. I know that's when it sounds like that, you've nailed it on parameter names. And yeah, okay, longest name, North Carolina. Longest name in dogs is that one. Okay, so this type of function is, I mean, depending on your app that you're building, hypothetically, it's a useful side tool that you can call on to solve a quick problem. Okay, 5B. Okay, 5B, we have a bunch of lists. We have, and they're all, no, 2 from states, 2 from countries. And let's see what we have, and then we'll see what we need to do. Okay, we have 2 calls to the same thing. And this is set up the same way as before, where the first parameter, okay, these are both to the same function called largest smallest, and they both use the first one to just hold a string that's only used as a part of the output concatenating so that it makes a sentence. The other 2 are we're sending 2 lists. Okay, and message is this combining. Okay, so it's all this concatenating. And there are many, hold on, okay. So what does this output look like already? Okay, many states, the one with the smallest population is Wyoming, the one. Okay, so smallest matching string, largest matching string. Let's read the description. Finds the string at the matching index of the smallest number in the list of the same length. So it's receiving 2 lists. One is a bunch of numbers and one is a bunch of strings. It sorts through the one with numbers and finds the one with the lowest number, but then keeps whatever's in the other list at that same spot. In this case, it is receiving a list of state population and state names. It goes through the state populations, finds the lowest number or highest number, finds the lowest number. And when it finds the lowest number, it gets whatever's in the state name at that same position. So it's returning the string of the lowest number that gets sent along with it. Okay. And here, this is critical to know which list 1 and list 2 are referring to. If you swap these, it wouldn't work. I mean, you could swap everything, but I'm saying when you call this, the first list is the list of strings, like state names, and list 2 is the list of numbers, which is state population. Okay, if you put the wrong thing in, it would be using numbers for strings and so on. Okay, the smallest one, it's accepting two lists and it's returning a string. Okay, we're doing the smallest number thing. We're only comparing against the number, the population number, but when we get something that is smaller, we want to keep, well, that smallest number for later comparison, but we also keep whatever string is at that index, and that's what we're returning. Okay, do follow the same pattern to do the next one. Okay, fix the largest matching so that it works the same as smallest matching. Yeah.
It says that it doesn't know what.
All right, let's keep moving. I want to make sure we get a bunch done. Okay, so this is going to set up the same way. We need introduction or declarations of variables that will hold the two things that we want. And largest number, and we'll give that, wait, which one's the numbers? Numbers is list 2. So we got to do that list 2 at index 0. We give it the first thing in the number list, which I guess is second list. Okay, and then largest string, which is the string in the matching position, but we will still acknowledge your sneezes. Okay, so string 0 or index 0, again, we'll give it the first element in each of those lists, and we'll run our comparisons. We'll loop through the entire, it doesn't matter. This only works if they're the same length, which kind of makes it less useful, but this is actually a very specific return function, makes it, less super useful overall. But we're going to go through the entire list of, wait, I guess list 2 is the one with numbers technically, not technically, literally. And if we're checking if list 2 index I, the one we're checking, is greater than the running champion, the running champion for numbers. And if it's greater than that, that's a match. And we want to reassign our two variables. Okay, the new largest number is whatever number we're checking. The largest number gets list 2 index I, and the largest string gets list 1 at index I. And the thing we're returning is that string, the largest string. Okay, and let's see if it works. I think it might if I can get any bandwidth. Okay, there are many states, population. Yeah. Okay. Well, there you go. This is a pretty specific use case for those functions, but that's that. Okay, let's go to 5C. Okay, 5C looks like this. All right, so we get a bunch of get columns, worldwide tracks. Wait, is this racing? Oh, no, it's songs. Got out of it. Okay. I thought it was like racetracks, but I didn't read the whole thing. We get worldwide tracks, artists, and positions that are all their own parallel lists. and USA Tracks artists and positions. And we have two calls to the same function, one with the information about the world and the other one's about USA track stuff. And we have a one thing to write, and it actually has nothing to do with the list they gave us. We are writing a generic list that will return a number that is a valid index in a list that is given as a parameter. Okay. That's all I'm going to give you. You are, well, no, that's a lie. I'm going to give you more. Okay. So it's expecting a list, and think about how you find a valid random index from any list. You're going to need a random number. You're going to need to put in a valid range, and you need to return that number. You can kind of do it in one line, but I'm going to explain it spread out. This is like a 30-second thing. Okay, and go. Okay, so it's receiving a list. We just need to return a random number between 0 and list.length -1. Okay, we don't even really need this, but you'll see rand index, and our code for rand index is random number between 0 and whatever list we get sent. List.length -1. For any list that gets sent, the range of valid indexes is between 0 and however many their items there are -1. And we can just return rand index. Okay. And wait, why is it not used? Rand index, rand song. Are we supposed to call rand index? Okay. Yeah. So this is where we're going to end up using it. I didn't introduce that, but we'll just do it now. But a second ago, when I said, so we introduce a new variable, but just as before, if you create a local variable just to, ship it out right away, I mean, that's what you could just do. That is kind of the correct answer for this. And then, so we'll leave it like this regardless. This function, you send it a list and it gives you a random number that corresponds to that index or a valid index. So anytime you need a random thing from a list, you don't need to rewrite the code. You can just say, okay, we're going to assign index var index gets random index, the name of the function, and then in parentheses, what list, variable index call random to call random index from what list? Oh, I guess it doesn't matter. It's those parallel list. So we're going to set var index to, hold on. We return var index gets random index of one of the lists that are here. I think. Give me a second. Although, hold on, assign a value to the variable index using a call. Yeah, that's fine. Okay, I think this should work. Yeah. Okay, so the way they're setting this up, it's kind of, this call right here is only replacing this where we put chart in the list. But the idea of having a call that just, the more complicated the return function is, like the more stuff it's doing, the more, I mean, for any function, the more it replaces the code you would need to rewrite. But this is only kind of replacing one line. But still, this function is calling rand index. Random index is the name of the function. it's calling that to do this calculation, and it's fine. It works all right. I mean, it works, but it's not mind-blowingly useful. And 5 D, the sleep in amp. Okay. So, okay, create a program that determines if it's okay to sleep in or not. Is this all we get? Okay. So create a program that determines if it's okay to sleep in or not. It is not, if it is not a weekend or on vacation, sleep in. If it is a weekday and not on vacation, get up. Okay. So there we have inputs. Input is going to be, well, let's look at the actual function. Okay, this function should return a string telling if it's okay to get up or not. The inputs are day, which is the name of a word, and, or excuse me, the name of the day as a string, the initial caps if it comes up later, and vacation is a true or false situation. Okay, so when it gets called here, it needs to send true or false as one of the parameters. We haven't done this before, using a Boolean as one of the things. Probably. Okay, so we need to set this up. We are expecting this Boolean and we're returning that. Okay, so what do we need for this? We need a output, and the output's going to be a string, and it's not always necessary to have one of these sort of local variables for the return. They put I don't know in there as a way of just having it not break if you run it right away, I believe. And we get two things, a day and true or false for vacation. We need to check. Okay, and if else is fine, because one of the else's is it's either sleep in or get up are the two outputs. So we can just go ahead and write the reassignings where if something output gets sleep in, wait, we need the string. Yeah, it needs to be quotes. We are returning the actual string. And the other one, output gets get up. The string. But what is the condition we're checking for? We're checking for, we want, it is not, if it's not a weekday or on vacation. Okay, so not a weekday is the same as is a weekend. So we can do this. If it's Saturday, or if it's Sunday, or vacation is true, that's sleep in. Any other scenario is get up. You could write it the other way. If is Monday or is Tuesday or, you know, all those things, like anything, but the shortest way is going to be this way. So we are checking against day and vacation. If day double equals, in quotes, Sunday or Saturday, I'll just do it in order. Saturday, or shift backspace is the vertical bars, and or day double equals Sunday, or vacation double equals true. And technically you don't even need to do double equals true or false for Booleans. You can just write it. If you write the name of the variable that's going to be either true or false, it exists by itself as true or false. And if you check just against, and I'm saying this without having checked if AppLab does it, but in out in the wild, having a variable that is, or in this case, a parameter that is true or falseness exists as true or falseness. Okay. And if you want to say is not equal to, you can just do if is not vacation. Okay. So, but let's leave it in here. Let's double check and make sure it works and then see if it breaks it. We'll see if AppLab agrees with that. Okay. So we're receiving a function or receiving a string. We're checking. We're returning that. Okay. So let's see what happens. We want Tuesday and is on vacation is sleep in. Sunday, not on vacation, is also sleep in. Friday, not on vacation, should be get up. And Saturday on vacation should be sleep in. Okay, so as it works, or as it stands, it works. Let's see if this is just a test. You don't need to rearrange things and write it this format, but I think it's going to work. We'd want, well, if it copies this, sleep in, get up, sleep in, we are going to be good to go. Yeah. Okay, so like I said, any variable or parameter that is true or falseness, you don't have to do double equals true, but that is fine. Okay, let's go on to, that was 5D. Let's go to 6, see what we got. Okay, simple ordering app that we want total with tax. There's a bug in it, and we want to add comments. Okay, we'll fix the bug and add comments to each function using the format below. Okay, you need to do this. Okay, this all needs to be your own words. Okay, so we have two functions here, total cost and total with tax. And let's throw some well, total cost doesn't have any parameters. Add comments for each function. I'm fine with just doing the second one because there aren't really even parameters. Well, there aren't parameters for the first one. Total cost apparently works because they say it does, but total with tax does not. Okay, let's see what we've got. We run and we choose. Is there anything that's easy to add? 325 and 375 should be 7. Okay, and total with tax is broken. Okay, so it doesn't even work. All right, so total tax, we receive an amount. Well, this is just a like check if you know how why is this open here? How return function is supposed to look. Give it a second and see what you think the issue is. If you've been looking and writing the return functions with us, it should be pretty easy. Think about the goal or the defining characteristic of a return function. The defining characteristic of a return function is that it returns something. Think about it that way. Okay, I'll tell you. We need to return total. There are times when you want to use a return that doesn't return anything. Return is like a break. It ends. If you have return in a function like this, this will end the function, even if it's mid loop. Okay, it returns kill it, which means that you need to separate some things if you are if it will overlap or mess up something. But that's more, well, actually, that's all the time in return functions. Like if you're checking for does something exist in a list and you're returning true or false, as soon as you find that thing in the list, you just return true, and that's it. Okay, so let's see if this works, that we're actually shipping back the new total or the total with tax. And what did I have before? This should be total 7 and total with tax a bump. Okay, so that works. All right, so let's go on to 7. This is wild. Okay, what's up? Yeah, go for it. Okay, so lesson, or excuse me, bubble 7. Wrong button. Let's try that one. Okay, so we've gotten this is the complement, random greeting, and complete the update screen function to following the instructions in the comments. Okay, when it works, the user should see a random greeting and compliment when they enter their name and click the button. Okay, so now we have some actual user interface, user-facing app for this. And we have our only input is the compliment button. And when you click the compliment button, it runs update screen. Let's see what update screen does. Update screen does nothing. Okay, this is what you need to do. Get the user's name. How do we get the user's name from something? Okay, or the input. The input is the user's name. This is like a 10 seconds or you're not sure. Commit to a guess, at least in your head. Okay, so we need to bring in the information. Okay, let's just call it username because that's what it is. And we need to get the text. And where do we want to get the text from? The name input. Okay, and create a local variable for text output. Okay, so the text output is going to be what we ship back. Okay, text, what was it? Output. And we want a string. Well, okay. So text output is, we are going to now actually call these functions. Okay, statement and statement. How does it combine? Oh, it's concatenating. Okay, so this text output isn't going to be an empty string. This is where we are actually calling the two functions, random complement, random greeting. Okay, so we want random greeting where we send it username. Okay, if you call this before, we would send like Sally or whatever the name was in quotes. Now we're sending the sending the variable username as the parameter, and it's working the same way. But we want our text output is the combination of random greeting and random complement. So we need to concat something else. How about, we'll probably want a new line command in there, concated with random complement, sending it username as the parameter. Okay, of course, concatenating is usually easier with text mode. It's more text-based. And so it's a call to random greeting, sending username, which is what we just got text from. New line command, I'm not sure if that's going to be the best output, but we can mess with that very easily. And then a call to random complement, always also sending username. And you need to make sure that your return functions are the green blocks. If you are block-based, that's how you know it is a function. Okay, and then our output is just going to return, or no, our output is actually setting the text. The return functions are the ones they gave us. So output set text, and we want to set the text of output to, what are we going to set it? Whatever the result of text output is. which text output is this combining of return functions. And let's see here. Okay, there we go. We have an output and we're assuming. Yeah, it's hard to tell that it's the next sentence because I didn't capitalize it. But there you go. We have these. Now we've used return functions. I want to make sure that we are pausing at a good place. Okay, definitely 8 and probably 1 of 9 will be where we end up, not positive. Okay, bubble 8. Okay, this is a cool app. Well, oh yeah, this is actually kind of a ridiculous app that we used to make from scratch, but there's a lot going on here. Okay, so let's see. The app is, let's see, it probably doesn't work yet, but when it does work, it's good. Okay, so this app is using a bunch of information, 4 lists from the 100 most influential African Americans list, and it's a quiz which requires a lot of randomness and you can see all the random calls and random answer. It's picking 4 names at random from the list of names, and I'm pretty sure they don't. Is there code for making sure that there's no duplicates? Random answer, random. Well, wherever the set URL is. No, wait, set text. Where is it setting the text for the different buttons? Set text of choice 1. Where is choice 1? Set the text of set text to random. Oh, random answer choice is what they're sending it. Okay. And random choice. All right. I got to break this down later. There's a ton going on here, but all we need to do is, well, I'll put it this way. I'm not going to go over all of this for everyone, at least not today. But if you are like interested in programming, breaking this down, there's a lot going on here, a lot of different systems in play. But what we need to do is to finish writing this function. Okay, this function is just checking if the guess was correct. Okay, user choice is coming in as a string, and correct answer is coming in as a string. Okay, adds 1 to the variable if the answer is correct. This is checking if their guess was correct, checking against which button or which name they choose from a button against a variable they can't see, because, I mean, if they could see the correct answer, it wouldn't be much of a quiz. And if they get it correct, we need their score, or if they get it right, we increase question number. Okay. Variable school, if it's answered, selected, and selected is correct. Yeah. Okay, so this one doesn't have an output. It is just a check for something. Check correct, choice 3. Yeah, okay, so it's just increasing the question number if they get it right, which I think is how the game controls how you progress. Of course, so we're checking if these are the same. If user choice double equals, eventually, correct answer. I wonder if this is what's killing my bandwidth. If the 2 things that come in are matched, we need to increase the variable named question number by 1. And there are, of course, 2 ways to do this, but we know it's a global variable, otherwise it couldn't be used by all the functions. And so we're just going to, well, this wouldn't work at all as a local variable, but we are increasing by 1, so it gets itself plus 1. Or you could just do the question number plus plus, but that requires going into text mode. Okay, either one of these lines works, but both of them makes it wrong. Okay, and I mean, comments are just wherever you don't need to. Wait, is this supposed to, what other variable is this messing with? Are we supposed to increase score if they get it right? Or is next question where they increase score? What do the instructions say? Complete the following instructions in the comments. When it works, there should be a new screen after 5. All right, so we should be able to do this 5 times. And okay, I don't know who anybody is, so I'm gonna guess something ridiculously wrong on purpose. Actually, I know who that is. Yep, probably not. And the 5th one. Wait, why is it stopping after? Am I not? Question number gets question number plus 1. Why is this not stopping? This should stop after 5. Who can find it? Comments. When it works, users should see a new screen after 5 questions showing how many questions they asked correctly. Why is it not? Are there more comments? Resets a global variable. One of the events calls new question. Maybe it's a new question function. What is the number? Question number. Oh, I think we got to do this one too. Hold on a second, folks. No, that's if, that's the else. If question number is less than or equal to 5, why is it not going to the, let's, hold on, let's put actually a watcher. Not even sure where to add it. A watcher for question number. Sorry, folks, we'll be done here momentarily. And we run it. And question number 1, question number. Why is question number not going up? If user choice. Check correct. Add 1. If the value stored in score. Oh, add 1 to the score, excuse me. I misread it. We are adding 1 to the question number regardless. What we actually need to be updating is score inside, which makes a lot more sense. You only go to the next question, or you only, the only point of checking correct is increasing score. So score gets itself +1, not +12. There we go. Okay, so this check correct does 2 things. It's checking if they got it correct and adding a score if it's right. But regardless, they add 1 to question number. The problem was before I didn't get 5 right, which would have been a false positive. So we'll just guess that's question 2. This is 3. This is 4. This is 5. We should go to an answer screen. Good. There we go. Okay. So there you go. That's what that needs to be. And that's 9 is the one I think that we'll do one of today. I'd like to get done with. Let's go like this. Sorry for being a little slow. We have bandwidth issues. Okay, I'm pretty sure we should be able to do this first one. In the past, these like one of apps, some of these have been entire class periods. So like this one lesson was like 4 blocks. We spent a whole block on each one of these in the past. Let's see what we're actually supposed to do for this year. Okay, so do this, rewrite the check answer to integrate a parameter so that the selection global variable is no longer necessary. Okay, so one of the ways that we can use parameters is to replace global variables. Global variables are not necessarily a bad thing, but in a complicated enough app, you're going to have, or you would have, a full page of global variables. That's actually kind of difficult to keep track of. You know, what's it called and where is it used and that sort of thing. Where sending parameters is like a magic portal from one function to another without needing to make it a global variable. Okay, so here we are using this global variable selection, which when it's called, it's updated, and then we call it check answer, and that's used in this function. This can be done without the global variable by sending it as a parameter. Okay, I'll give you a couple minutes to figure it out. Okay, you're sending something from the check answer call to the check answer receive, and you need to adjust a couple things. Okay, and that'll be the last part of today. We'll go over it shortly, but give it a shot. It'll be good. All right, let's just wrap this up. So we can use the same name. Hold on a second, folks. Nearly done. Okay, so instead of making a global variable just so that we can use it here to get the text and make it uppercase, which always a good thing, and then used here, we don't need that global variable. We can use the same name and pretend like it never existed. Okay, so instead of having selection all over the place, we can just send what we wanted to send into check answer as its only parameter. Then check answer is going to receive that, and we'll receive it as a name. We can call it anything, actually. Let's just call it selection. That code already exists. Okay, so without any sort of update at the top or any sort of declaration, we can call check answer, send it what we wanted to send, which was just the get text from the text input to uppercase so that we can do our comparison here. And when it's received, or when the function is the definition, it is expecting a parameter, expecting a value, which we can name anything, but we named it selection just so that this already worked. And if that parameter that's being received matches whatever's in the particular index of the thing it's comparing against, which index is still the random number thing, set the property hidden to false, meaning hidden to false is a weird thing, just means showing. And then if it is not a match, we get frowny. It hides the correction box it shows the correction box and it sets the output text. Let's see if this works. Okay, is that a L? Yay, got it. Try another. Okay, I don't even know. Is this? Wow, it put up the first two that I know. Yeah, do I know these? Anybody know? X. Oh, very good. Impressive. Okay, so now it works without needing that global variable. It's one less global variable to crowd up the top, and there's just no need. It's like a magic portal from one function to another without needing to declare it at the top. Okay, so that's where we're going to end it today, actually. We'll pick up the last three of those, put it all together, the check for understanding, and the entire next lesson next time.